index table. So there is no constraint on the index part, and it can have a multi-set or set combination target tables. Yeah, and it can have be populate or empty table. So it can populate the empty table or it can populate already populated table. Tables can have triggers. So no constraint. Basically, you can say there is no constraint on the target table if you want to use with the tpump. The constraint is it can load low volumes of data as we take, and it allows conditional processing similar as multi-load, and it has support to automatic restart and the user support environment. So it also has a log table and restart checkpoints. So it has the restartability, and it has support environment where it can accept variables from the external files. There is no limit in the number of utility sessions in the tpump because it won't occupy the loader slots, similar as BTEC, where BTEC won't occupy any loader slots. So similarly, tpump also don't occupy any loader slots. Which tools occupy loader slots? The fast load, fast export, and multi-load. These are the load utilities, and these load utilities has a limitation in the number of utilities we can use concurrently. So as we have touched base this concept, we'll see what is the limitation of the sessions here. Starting with V2R 6.1, the max load task and max load amp work time parameters determine the maximum number of utility jobs that can execute at a given time. Teradata can accommodate not more than a combined total of 60 utility jobs at any one time. Then combining fast load, multi-load, and fast export, you can run maximum of 60 utility concurrently. All three together can be up to 60. And within this 60, combining fast load and multi-load, you can run up to 60, up to 30. The loaders, the fast load and multi-load, they can occupy up to 30 loader slots concurrently. Okay. And whatever sessions remaining, okay, from the 60, whatever loader slots already occupied, we have to subtract it, and the remaining sessions can be occupied by the fast export. Okay, the fast export limit is the total count 60 minus the current occupied fast load and multi-loads, that is fast exports. Okay, so for example, currently I have 10 fast loads running and 5 multi-loads running. Then how many fast exports I can invoke? By seeing this formula.
45.
Yeah. So for fast export, the formula is 60 minus currently executed fast exports, fast loads and multi-loads. It is 10 plus 5. So 60 minus 15, it is 45. Again, one more example. I have 30 fast exports running, 10 multi-loads running. How many fast loads I can invoke? So I write down here.
20.
20.
Okay. So let me tell you. 30 fast exports, 10 multi-loads running. So how many fast loads I can run? Tell me the formula so that everyone can understand.
60 minus 30 minus 10.
Okay, let me write down the formulas here. For fast exports, it is 60 minus currently running fast loads plus multi-loads. And fast loads and multi-loads combinedly, they can run up to 30. And totally, Fast exports, fast loads, multi loads together is 60. And it's clear?
So
All together is 60. The loader slots are maximum up to 30, and fast exports is 60 minus currently running fast loads and multi loads. So now fast exports 30, multi loads 10. How many fast loads I can run? So which formula you use here? See, fast loads and multi loads as a combination, how many you can run?
30.
30. And multi loads are already
10. Yes.
10. So how many I can invoke for the fast loads?
20.
Right? Good.
So does this means Teradata can support 60 slot loaders?
Yes, it can go up to maximum 60 with the combination of all fast export, fast load and multi load. After 60 it will be in delayed queue. So once one of the session is completed, then only it can get the resource, the loader slot. Let us do one more exercise. Okay. Currently I have 10 multi loads plus 5 fast exports running. How many fast loads I can run?
20.
Again same 20, because if I ask for the load, we have to see the other load only. If it is 10, so the loads together should be 30, so you can go for 20 more. That's it. You no need to consider exports. Okay, if the question is about the load, in the input you have to see only the loads. Okay, or if it is 20 ml, let us see, it is 10 fast loads plus 20 multi loads. Then how many fast exports I can run?
30.
60 minus 10 plus 20, right? So number of fast loads plus 20 multi loads, it is 30. So 60 minus 30, 30. So this is the formula which you need to work on. So totally 60 loader slots are, the fast load and multi load combinedly are 30. Yes, and fast exports are 60 minus currently running fast load and multi loads. So this simply you can make this calculation and can give the answers. Clear? Anyone? Any question? Okay. And if you observe, there is no limitation on the BTQ and tpumps. See here. So for BTQ and tpump, there is no limit in the number of loader slots and the number of concurrent instances running. There is no limit in BTQ and tpumps. Okay, so tpump is moreover having the features from BTQ and the features from the multi-load. So it is a hybrid in between BTQ and multi-load, where it can do all the operations of multi-load with low volumes, and it won't occupy any sessions similar as BTQs.
Manoj,
Yeah.
I have a question. When we say T-pump is used for low volume batch modes, right?
Mm-hmm.
So, but in the banking sector, there are a lot of these large volume transactions are there. So how it can be used in banking?
That's what I mean. It is very legacy tool. Nowadays it is not used, because if it is less data, we'll go for BTEC. If it is huge data, we'll go for multi-load fast load. So it is very legacy. So here my effort is to just make you understand, because some legacy applications which are already implemented, there you may see this tpump is currently running. But most of the times when we are getting performance tuning projects, one of the performance objective is to change all tpumps to btex. So that's why
Okay.
the usage is less, but as per legacy, when they implemented, they might have used it, and currently they may be running. But if there is any opportunity, they are trying to convert it to btex.
Okay. So there is no utility which can be used for active data warehousing.
Yeah, in banking, it is not very much required, right? So there is any such, I mean, it is very rare where you maintain the active data warehousing. In their scenarios, they may use these tpumps.
Okay.
And it uses the row hash level locks because it is low batch operations. It it don't lock the whole table together. So it locks the row level locks or row hash level. That means the rows which are having the same row hash value are logged together. So the table is available for a long period.
So that's the advantage of this.
Yeah.
So we can use do the DML operation on the rest of the rows, right?
Yes.
Which are
So
not
the
locked.
the table is not locked. The totally table is not locked. So it is a row level operation. Sorry. It is a row level operation. So the table is available for read purpose for other users, and I'm loading it from tpump here. So that is advantage. So there are so many advantages, but the complexity is if something happen, it clot all the tpumps. I mean all the sessions. See here, Vijay has mentioned they have one project to convert tpump to multi-load. So that's what happening. So tpump is being migrated if it is less data to btech, if it is a huge data to multi-load. So like that, it is being not used.
Manohar, the row hash level locks means it's not a row lock, right?
Uh,
Row hash level lock means
row lock. I mean, in case of unique primary index, the row hash and row lock are same. But
same,
in
yeah.
case of non-unique primary index, there are number of rows with the same row hash value. So there we cannot say one row. It is row hash. Means it can be multiple rows with the same hash value. Right? So it locks only that particular number of rows which has the same row hash value at one time, so that all other table is available for the transactions. It can always be stopped and locks dropped with no ill effect. And locks can be dropped automatically with no ill effects. Designed for highest possible throughput. Throughput means continuous loads. Within a time, you can specify a rate. So within this minute, you can go maximum up to 60 records only, or you may increase that, so that you can control the throughputs in the tpump with different parameters. Users can specify how many updates occur minute by minute, can be changed as the job runs. You can observe how many rows are coming from the source, and you can control it externally how many rows it can load at a time by minute. The rate of update. And limitations are you cannot use the select operation, concatenation of data files are not supported, how we did in fast loads, and exponential aggregations arithmetics are not allowed, similar as multi-loads and fast loads. There is limit of limit of 4 import commands within a single tpump load task. You can go 4 import tasks, and each import task can have 128 DMLs involved in it. In using tpump with the dates before 1900 and after 1900, the year portion of the date must be represented with the 4 numbers format. So the default double Y format takes the 20th century, that is 1900s. If you want to represent the years before 1900 and after 1999, you have to specifically give the format in the YYY format. And this is a sample script where it is similar to the tools what we learned so far. Just I've given a snapshot here. The log table, the log on statement, begin load, and the number of sessions you can maintain, and the serialize on, The serialize on is to make a amp work on a set of key records. Okay, if you see, account number is the key here. So all the values of this account number will be processed by a single amp. That is called as serialize on. If you give serialize on, it expects at least one key column in the load, and as per this key it will maintain in such a way that all the rows of the same key will be processed by the same amp. That is a feature here in the tpump. And then pack, so it will pack 20 records as a single IO and it will make the operation. Rate, per minute this many number of records has to be processed. You can give error tables, error limits, okay, which you have seen in other utilities. Are you able to see now? So begin load, sessions, serialize on, pack, rate, error tables, error limit, and then the layout, and then the DML labels. What are the labels? What are the DMLs we have to apply on the data? Import in file, data file, layout, using layout to apply this particular DML where the table code equal to A, T, C, A, T, C, so that conditionally you can apply the DMLs on the data. Pack, rate, and robust on. Pack, we know, to improve the network channel efficiency by reducing the number of sends and receives between the application and Teradata. So to reduce the IO operations, we will combine a group of records into a single batch so that it will be moved at once by reducing the number of IO operations. And then rate, it sets the initial maximum rate at which the statements are sent per minute. Default is unlimited. You can specify a value to control the number of amount of work sent to Teradata. Example, if rate is 12,000 and if we give in a parameter called pack 20, then totally how many packets will be per minute? Okay, here the rate is 12,000 per minute we are saying, and we have given a pack of 20, so how many packets per minute will be transmitted? 12,000 by 20, 600 packets per minute. So 600 IO cycles would happen. Like that, you can calculate the combination of pack and rate, how many packs and how many IOs would happen per a minute. And per second it is 10 packs. Per second 10 packs are populated in such a way per minute 600 packets are moved. So per minute totally 600 IO cycles would happen. We have robust on, which is default. This option is to avoid reapplying the rows that have already been processed in the event of restart. For example, it has all the checkpoints and all, but it allows the duplicates also in the multi-set tables. Yeah.
For one packet, there should be two IO operations, right?
Yeah, when I say IO, input and output. One
So
input and one output.
There are two operations, so per packet there should be two operations.
When I say IO, it is two operations basically. Right?
Okay.
I means one operation, O means one operation.
Okay.
So that's why I say 600 IOs means yes, internally it has to have double 1200 operations. 600 inputs, 600 outputs.
Okay.
Right?
Right.
And this option avoids the reapplying of rows that have already been processed in the event of a restart. If I restart, it should start from the last checkpoint onwards. Okay, and when it starts from the last checkpoint onwards, some records might have already processed in the previous run. In order to not to load them, we'll use this robust on. It is default. If you put a robust off, then you may have a chance that it will populate already loaded records in case of a restart. For example, I have 1000 records and I have a checkpoint of 100. So each 100 records it maintains the checkpoint, and my load failed at 220th record. Okay, 220. And when I restart it, from where it will restart? The last checkpoint 200. So 201 onwards it will start loading the data. But the 20 records which were already processed earlier, they will also be again loaded. Right? So in order to avoid that, you can use a robust on, so that during the checkpoint, okay, after the checkpoint also it will maintain the internal checkpoints, so that you can understand the 20 records were already populated, and it won't populate from 220 onwards. I mean, it won't populate from 201, it will populate from 221 onwards. Okay, so there is some internal mechanism with a overhead which you can maintain robust on, which is overhead again, yes, but to avoid loading duplicates during the restarts, you can use the robust on option. If you are inserting into multi-set table, it is very much important. If it is a set table, the set constant itself will throw out that record. But if it is a multi-set table, yes, you have to use this robust on operation with the tpumps. The pack factor are large, and applying and rejecting duplicates after a restart would be time consuming. Yes, it is overhead. So if it is set table, you no need to use a robust. If it is a multi-set, and if you are loading, you have to have the robust on option. And this is the serialize example where this is our key, and these are the tpump buffers where each amp will access the data. So here, if you put a serialize on, what happens? If this one is processed by this first buffer, all ones would come into this buffer only. And if 2 is here, so all 2s will be here. And 3s, all 3s, 8 and 6. So here there will be some internal operation where it will make all the rows of same property, the same keys are processed in a synchronized basis. The serialize guarantees both input record order and all records in the same PI will be handled in the same session. Okay, when you have the multiple sessions, it will try to ensure all the same key values are processed in the same session. Okay, it is recommended to specify the PI, the statement column, as key, where we are defined as a key here. So based on this key, all the rows of the same key value are processed in the same session. Okay.
I have a question. Can you go back to the previous slide?
Sure.
Yeah, here, yeah. When we are working on a file, normally the records may or may not be sorted out in the file, right?
Yeah.
So how it is going to decide, okay, buffer 1 needs to have this much space to store those records of the same PI, how it is going to know, like some temporary space is going to be allocated for this buffer?
Yeah. So they'll have, see, this load utility, the main functionality is to load less volumes of data very frequently. Right? So when it is estimated very less number of data populated in a single session, at that moment, if whatever data is coming, okay, it is very less space required probably. And within that space, it will identify what all records are having the same key values, and in that session, which are arrived within these timings are maintained in the same session. If you see the session 1 and session 2, okay, they are between the time window 8 to 8:7. So within this, whatever rows come with the same key, they will maintain in the same session. All ones are maintained here, all twos are maintained here, all 3, 4, 5s are maintained here. Okay, so this is how the synchronization works. And after 8:7, whatever rows come, they will be again distributed across two different sessions. 8, 6, 1, 2, 7, 3. No 7 comes here, no 8 goes there in this time window. Like that. The first session, first time period, 2 sessions will be taking some estimated space and it will be applied. And then the same 2 sessions but with different data and the different timings, they will be synchronized and loaded into the apps. Is that your question?
Yep, thanks.
And this is application checklist. Yeah.
So in the tpump buffer, the data is stored in the basis of the PI?
The basis of keys. If you make these serialize on option, and if you make one column as key, then this will happen. Otherwise, no need to make a synchronization. So whatever session can populate the data, it will pull and load into the apps. This is all about serialism.
So in this case, we have a key is PI.
Yeah, here it is key is PI. Yeah.
Okay, so all the rows which have a like a primary index 1, they should be in the first one, right?
See here, not the primary index concept. The column name is PI, but it is a key while loading into the target table. It is not physical primary index. The column name here is maintained. Here if you see the account number, it may not be a primary index, but I have mentioned it as a key. So while loading, it considers this column as a key and makes it synchronized while applying in the table. It is not required that it account number could be a primary index. Here the column name it is showing as the primary index. Okay. So probably it could be key also. Yes, what you said is true. Most probably the primary indexes are considered as keys, but it is not necessary always. Right?
Okay.
And this is the application utility checklist, where it will give a snapshot of all the utilities, the features, the limitations, and the activities. So you can compare the features against all the 4 or 5 utilities, so that you can have a good understanding and the knowledge at what time, what type of utility is suitable. DDL functions. Everything is accepted in BTQ. In fast load, very limited. In fast export, yes, you can use it through the support environments. Okay, and yes, multi-load also you can use it. tpump also can use it. The support environments. And the DML functions, everything can use in BTEC. Only insert in fast load, only select in fast export, insert, update, delete in multi-load and tpumps. Right? Multiple DMLs. Yes, you can use in all the utilities except the fast load. Okay, it is only one DML we use in fast load. Only one insert. Right? And multiple tables. In all the utilities you can load multiple tables except the fast load. Fast load you can load only one empty target table. isn't it? The protocols used, the SQL protocol in BTIC, fast load protocol in fast load, export protocol in fast export, multi-load protocol in multi-load. Again, tpump and BTIC are same in the protocol, SQL protocol. Conditional apply exists only in multi-load and tpump. You have seen at the end of the multi-load script, it can check the condition and then apply corresponding DML on the records. So conditionally, you can apply the data in multi-load and tpump. Data conversions. We can convert the data types in all utilities, but in fast load it is one time per a column. You cannot convert one column two times in fast load. Error capture. In BTQ, we don't have no error capture because no error tables. But all other utilities, yes, you can capture it. For fast export, it is not applicable because we are exporting data from RDBMS, so there is no chance of errors. Error limit, yes, for all loader utilities along with tpump, it has the error limits. BTEC, we don't have error limit. For the first time error itself, it will come out of it. There is no tolerance here. Fast export, yes, there are no errors expected, not applicable. The in-mode routines and out-mode routines, cannot use it in BTEC, but all other utilities you can use either in-mode or out-modes. For load, you will do in-mode routines. For exports, you can do the out-mode routine. There is no restartability in BTEC, but in all other utilities, you have the restartability. Maximum load limit, it won't exist for BTQs and tpumps, but for these three utilities together, you have a maximum load limit. Support environment, we don't have for BTEC and fast loads, but all other utilities, we have support environments where you can accept variable values from the external file systems. Yeah, so this is a total snapshot of all the utilities. Okay, so now a sample question. I have a target table where I need to load some 200 records of data and it has a secondary index defined on it. What utility will prefer to load these records?
T-
200 records.
tpump.
Why tpump? Can't I do with the BTEC?
Yeah, we can do it
Then why you prefer tpump?
because the sports was candidate next.
I told you right. Tpump. Okay, if it runs good, it's fine. But if it is, there is no need of doing the active warehouse maintenance. Don't go for tpumps. Okay, so don't prefer tpumps because nowadays everyone is moving out of tpumps. It is just for theory purpose and just for knowledge purpose I have given this session. But tpump you just avoid as much as possible to implement. Okay, so it is BTEC. You have to prefer when you have less number of data. And I have 1 million of data. I have a unique secondary index defined on the table. Which utility will prefer? Shall I repeat? I have 1 million of data and I have a unique secondary index defined on the target table. What utility you will prefer?
Multi-load.
Why can't fast load? So Vijay, you said fast load. Why? I mean, how you can use fast load?
So
Fast load.
we have
Yeah, would fast load supports the unique second index? Is
no,
it?
I don't think so. Yeah. doesn't support the secondary indexes, right?
Pardon?
The fast load does not, fast load and multi load, they does not support the secondary indexes, right?
No. Fast load doesn't support any index, and multi-load supports non-unique secondary index, where the amps are same for the subtable rows and the base table rows. Right? So here the answer is yes, you may load it through fast load, but you have to do a workaround that you have to drop the secondary index before you load, and you have to recreate the index after this. So you have to calculate how many resources are required from dropping onwards, loading until create, and then you do the same thing with the multi-load and see which is better performing, and you will choose it. Yeah. So by default, fast load cannot support the unique second index. It will throw an error. Multi-load, no, it can all it also cannot support unique second index. The multi-load can support only the non-unique second index. Okay, so what's the workaround you can do is you can drop the utility, you can drop the index and then load the data and then recreate the index. Okay, this is the one workaround approach you can do. Otherwise, you see if the data size is less, the number of columns are less, even it is 1 million, you may try the BTQ and see how much time it is taking. If it is very highly consuming, then you go for this approach of dropping the index, load the data and recreate the index. Clear? So fine then. So tomorrow we have only the DBA session. We don't have the development session. Just a moment. Okay. So tomorrow we don't have the DBA session. We have only the development. We have the DBA session only. We don't have the normal development session. Okay. On 8 a.m. we are going for the new batch inauguration with the demo session. So if you have any of your friends or colleagues who are interested in, please give us the mail IDs so that we can forward them the formal invites. They can join the demo session and they can join the batch, which may be starting from 13th of December onwards. Yeah, go ahead please. Some question?
Can you show me the table which you created?
For what?
I have a question like DML functions and DML something. I didn't understand that one.